A shape has rotational symmetry if you can rotate it by part of a full turn and it still looks exactly the same. To illustrate this, here's an equilateral triangle. The top corner is marked with a red dot and a line so we can keep track of it when the shape rotates. The grey dot shows the centre of the triangle. If we rotate the triangle through 1/3 of a turn, it maps back onto the original shape exactly. If we rotate it through 1/3 of a turn again, it also maps onto the original shape exactly. If we rotate it one more time, it is back to its original position, with the red corner at the top. We use these 3 circular arrows to indicate that the triangle maps onto itself when we rotate it by 1/3 of a turn. Now let's morph the shape into an isosceles triangle. This time the triangle cannot be mapped onto itself. It needs to turn through a full turn before it matches the original position. The single circular arrow indicates this. Rotating the shape by a full turn just puts it back in exactly the same place as it started, so we say this triangle has no rotational symmetry. To recap, an equilateral triangle maps onto itself if we rotate it by 1/3 of a full turn, or 120 degrees. This means that there are 3 different positions that look the same, so we can say it has rotational symmetry of order 3. Any other triangle needs to be rotated by a full turn, or 360 degrees, to map onto itself. This means that there are no other positions that look the same, so we say it has no rotational symmetry. We can say that it has rotational symmetry of order 1, but that isn't really symmetry because the shape is rotated right back to its original position. A square has rotational symmetry of order 4. A square rotated by 90 degrees, or 1/4 of a turn, maps onto itself. We can do this a second time, then a third time. The 4th time it is back where it started. A rectangle only has rotational symmetry of order 2. A rectangle rotated by 180 degrees, or half a turn, maps onto itself. Rotating it a second time puts it back where it started. A trapezium has no rotational symmetry. It must be rotated by a full turn before it maps back onto itself. In this example, the trapezium has a vertical line of symmetry. It is possible for a shape to have line symmetry but not rotational symmetry. A parallelogram has rotational symmetry of order 2, similar to a rectangle. A parallelogram has no lines of symmetry. It is possible for a shape to have rotational symmetry but not line symmetry. A rhombus is a special type of parallelogram that has 4 equal sides. A rhombus has 2 lines of symmetry along its diagonals. A rhombus still has rotational symmetry of order 2, just like a parallelogram. A kite has no rotational symmetry. It must be rotated by a full turn before it maps back onto itself. We saw earlier that a regular triangle, that's an equilateral triangle, has a rotational symmetry of order 3. A regular quadrilateral, a square, has rotational symmetry of order 4. What about a regular pentagon? This has rotational symmetry of order 5. We rotate it 5 times before it returns to its original position. Finally, here's a regular hexagon. It should be no surprise that it has rotational symmetry of order 6. In fact, any regular polygon has rotational symmetry of the same order as its number of sides. If you enjoyed this video, please subscribe or visit graphicmaths.com. The link is in the description below.